Thank you very much, and off we go. So the title of this talk is What's New in CameraX, which is slightly different from what it says on the agenda. We just like to play fast and loose with the organizers here. So what's new in CameraX? First, very quick recap. We announced the alpha version in Google I/O last year. As an alpha version, it was very early stages. The API has changed, not very significantly, but it has changed since then. We've had a tremendous amount of community support and excitement around CameraX, which has been nothing short of amazing. I really appreciate all the feedback, all the support you guys have given. Just please keep it up. And we also have some new functionality that we have added since then. And that's what we're here for. So the main three things that we want to break this down into is API changes and API additions. We also have enhanced stability. Basically, we want to increase the confidence that developers have in being able to use this in their production applications. And then we have what we call extensions. Extensions is essentially a way for developers to utilize capabilities that before were only available to first-party camera apps. That means that if I have a Samsung phone, only the Samsung camera app was able to use some of that stuff. Now we're opening up a whole new set of APIs that allows us, third-party developers, to make use of everything that the phone has to offer. So first in the API, we have listened to all of your feedback, and we have added a few new APIs that are sorely needed to close the gap between what you can do today in Camera 2 and what you were able to do in CameraX. We'll be talking mainly about camera controls. We have a few examples here. We'll go through those later. And then we also want to call out that we are working very hard on compatibility. Any new APIs we add, we're going to make sure that they work for all devices out there, so you don't have to worry about that. So speaking of compatibility, we are doubling down on enhanced stability. We basically understand that having consistent behavior is a pain. Not only do we have different API levels and different library version levels or library versions, but you also have within each device category different behavior. There's at the HAL layer, you have different HAL levels for the camera API, and you as a developer sometimes have to check that to understand what capabilities that the camera have. We try to make sure that all of the APIs that we add for CameraX, they work for all devices out there. We try to go for the base layer. We are focusing on the core features, and we are making sure that all of those are well tested. We have a big device lab, and we're, as I said, doubling down in the amount of devices and the amount of tests that we run on all these devices. So a little intro to extensions. In my opinion, this is one of the coolest features. As I was saying earlier, is stuff that before was not available to developers. It was first party only. So if I had, as I said earlier, a Samsung device or a Motorola device, only their camera app that shipped with the device was able to take advantage of some of those very advanced capabilities. We are now working very closely with all these OEMs, and we are integrating these capabilities into a standard API that all developers can use. For example, being HDR, night mode, and so forth. So just to name a few, these are some of the guys that we're working with. More to come, obviously. And here's an example. For Motorola devices, my understanding is that starting in Android 10, every single version of Android will have standard support for extensions. So when you have a Motorola phone and you're writing your CameraX app, you will be able to activate night mode. And the difference is quite striking. It's not like day and night. It is like night and night plus. One other thing I want to call out is we are working very closely with LensGo team. This is a real production app which has real challenges and that has helped us step it up to the next level when it comes to the CameraX library. For those that are not familiar with the LensGo app, it is built into the Google Go app and essentially has a little button that activates the camera and lets you do some real-time AR type of stuff. In this case, they have real-time translation. It really is as good as it looks. It's quite incredible. So the the LensGo team struggled with Camera 2 like every developer out there. We have Google engineers, but they're still not magicians. The Camera 2 API is just hard to work with, and there's a huge problem when it comes to the compatibility, especially for apps like LensGo that are targeting the low-end market. Those low-end devices is when it really gets tricky being able to write a single code base that works across all those different API levels and all those different devices, all those different chipsets. So for us, this was a great case study opportunity. We wanted to understand what does a real-world app need from a CameraX library to make this work for everyone. So we got some direct feedback from the LensGo team. We were able to identify a lot of production issues. For example, we found out that initializing the code that CameraX needs upon app startup is not always a good thing. So we had to add some toggles, add some flags that lets app developers postpone that initialization. That's just one of the examples of the many things that we identified through working with this team that camera apps in the wild have to deal with. We had amazing results all across the board. The main one that I found surprising was the APK size. I figured, if you're using a library that we are providing for you, chances are you're going to include some stuff that you didn't really need. Turns out the LensGo team had a lot of compact issues, and they were using device-specific code, which increases, number one, your code base, but they were also not doing things as efficiently as they could have. Because this library is built by people that are not only experts in Camera 2, but many of them worked on the Camera 2 APIs, they have a much better understanding that any other app maker can possibly have about camera. So in that case, we were able to build and provide a much smaller library than what they were able to build themselves. So now it's time to see some code. Before we cover what's new, I want to do a very, very quick recap of the very basics. This is not an intro to CameraX talk, so I'm just going to give you the 90-second version. The basic element of CameraX is called a use case. We have 3 core use cases in CameraX. First one being preview. Second one is image analysis. This is when you do object detection or AR. Those type of use cases are what's enabled by the image analysis use case. And the last one is capture. This is essentially when you want to capture an image and save it onto the device. It is a very straightforward API. There are 3 basic steps involved. Depends on how you break it down. I'm making it 3 here. We are going to use image capture as an example. Say that I have an app and I want to capture photos. Just take pictures. First, we specify parameters like the resolution, and we build our use case configuration object. The problem here is that one of the challenges, Android users love Android because of its diversity. That is both a blessing and a curse. That means that for us app developers, it is very difficult to build an app that works across all these devices with a single configuration. The way CameraX solves this is through graceful degradation. It falls back to the next best thing, or what we consider the next best thing. So in this example, if this resolution particularly is not available for the device that you are targeting, we're going to fall back to some other resolution to make sure that at least you have something working. It may not be exactly what you wanted, but you will have something that the user can interact with. Another problem is that there's a lot of life cycles in a camera app, in apps in general. So we have things like activity lifecycle, fragment lifecycle, the camera device, the camera session. There's a lot of things going on. For that, we lean on the Jetpack and architecture components lifecycle management. So the idea is that now you have your lifecycle, which could be coming from a fragment activity, whatever it is that you have that you care about, and then you bind your CameraX object onto that lifecycle. What that means is that then the camera will open when your lifecycle starts, and it will close when it ends, and you don't have to worry about any other state management. That's all taken care of for you. And then at last, you interact with the use case. What you're doing in this case is using the function that's provided by the use case, which is just the take picture. Simple as that. This is not the whole app, but this is as is the entire image capture pipeline. and it really takes a lot less code compared to Camera 2. And that was I guess, a little longer than 90 seconds, but whatever. Finally, we have to talk about what's new in CameraX. So the two most important things I want to talk about are these new APIs called Camera Info and Camera Control. The idea is that for one of them can control the camera object independent of the use cases, and in the other one we can retrieve the general information and state of that camera that is being used. Some of the examples that we named here are zoom, focus, flash, those kind of things. It wouldn't make sense to have, say, for the preview use case, flash on, and for the photo use case, flash off. That stuff is at the camera level, so it needs to affect all use cases. And for that reason, instead of adding that configuration into the use case objects, we've created a new API, which is Camera Control. And then there's the other corresponding API, Camera Info, to retrieve that state. The reason why they live in separate places is they're not always matching. Say, for example, that I set flash to on through Camera Control. It may take a few milliseconds until that actually kicks in. For that reason, Camera Control is, in general, going to return a feature. And when that feature completes, that means that the API has actually taken effect. And the Camera Info is going to give you some sort of live data object that is going to update as the state of your camera changes. So now let's go through a few of these examples. Let's talk about tap to focus. This is a very, very common use case for camera apps. If you have ever tried to build this on Camera 2 in the past, you are in for a treat. This is very gory, very complicated, very hard to do. So one of the main issues is that you have two different worlds. In one side, you have screen coordinates. That is where your view is, and that's where your user is tapping. And on the other is your camera coordinates. That could be completely different things. You don't really know how they map with each other. There's a lot of linear algebra involved, and let's be fair, no one wants to do math in their app. So we have really simplified this flow when you use CameraX. In this example, we're going to use texture view, but just so you know, there are other methods for other types of views. I think as of Alpha 06, CameraX will now start supporting surface view. 06, probably 7. By beta, for sure, it will support more than texture view. So the idea is that with this code, we create a metering point. Those are what I'm calling view agnostic coordinates. Those are coordinates that are neither in your view space nor your camera sensor space. And then we create this using our factory method provider. With that, we build an action. This action is the metering and focus action. In Camera 2, those are two separate things. In the vast majority of cases, you want to do both at the same time. So we provide a single action for CameraX combining those two. So the idea is that we build this action from the metering point. One thing that may not be obvious is that you can add more than one metering point if you want to have focus and metering more than one point at the same time. And then with that action, we pass it to the camera control to actually perform the action. As I was saying earlier, this is going to return some future object, and then you await for the feature to complete. And that's when the focus has actually converged. It really is as simple as those three things. If you compare that to Camera 2 code, I'll be doing a whole other talk just explaining how you could do it in Camera 2. So this really is quite an improvement, and I'm personally quite excited for how much easier we're making this for developers. Another thing, historically quite complex, is the zoom. Another very common way of camera apps to handle this is through pinch to zoom. This has similar complexities, reason being the same. You have two different coordinate spaces with the added problem that now you have the user actively acting on your views and dragging and pinching, and that can get gnarly as well. So in this case, to compute the actual zoom, we need two values. We need the base value and we need the delta, and with that we compute the scale. So to compute the delta, we use the standard gesture detector. This is pretty simple stuff. We add a listener, And let's define the listener now. So we use camera info to get the base value. As I was saying earlier, camera info is going to be the best way for you to understand what is the current state of the camera. So we use camera info and we retrieve what is the current zoom value of our camera state, our camera session. And then we compute the scale based on the delta between that base value and what the detector has given me that the user has actually pinched or what's the opposite, unpinched. And that's our factor. And then we just use the setter. We have a convenience method called set zoom ratio. We set the scale, and that's it, really. This is as simple as it gets. For building pinch to zoom, again, we are talking about hundreds of lines of code that it would take for somebody to build a reliable pinch to zoom. This is another huge win for developers. And the last one is the zoom slider. You may think it's basically the same, and it is in fact very similar, but it is different in one very fundamental way. So for example, suppose that I have a camera that zooms from 1 to 10. This is the zoom ratio. When I go from 1 to 2, I am reducing the field of view by 50%. I'm making things twice as big. Whereas in the last two, from 9 to 10, I'm actually only shrinking by 10%. It's not quite linear, and it is not a good user experience. Once again, you could do this yourself, but who wants to do math in the app? So as a convenience method, we have provided a zoom percentage API. This one is even simpler. All you have to do is to provide a value between 0 and 1, and that's what the zoom will be. 1 being the maximum zoom that the camera supports. Keep in mind that those values are not set. I could have an app that supports multiple cameras, and I switch from front and back. Front camera may have a maximum zoom ratio that is different from the back camera. By using the percentage, it's always going to be between 0 and 1. So it is much easier for me to handle that as a developer. So we have talked about a couple of the APIs today. Some of them are not yet available. My understanding is that they will come out for beta, if not sooner. These are some of the things that we're building. Previously we had, for example, texture view. That was the only one available. Soon we'll have surface view, potentially others, some view widgets that we're working on. We can't cover all of the features in this talk. If you're interested in seeing more, we have the dev site. Highly recommend that you take a look. We also have blog posts, videos, we have the official sample. One thing that I want to call out is that for the samples repo, it's not just for CameraX, it's for all of the camera samples, including Camera 2. And we try to use those GitHub issues for issues that are related to the sample itself. If you have problems or questions about the camera library, you should probably go to either Stack Overflow or our AOSP issue tracker. We have a hard time keeping up and helping all the developers that are asking questions about the library for within the GitHub repo. We also have a dev mailing list where you can talk directly with engineers and the program managers. That is at, should I add a link? It is g.co/camerax/dev. And then one last thing, we have beta coming up in December. This means that the API will be stable, that we have higher code quality, less bugs, hopefully, and it is ready for production. We understand that beta is not production, but we have seen in quite a few cases that even in the alpha state, developers report that the CameraX library is already more stable and better performing than the previous Camera 2 code that's developed for months, if not years. So take a look, give it a try, and I think that's all I have for you. We are ending a little early.